Hello everyone. In this video, I'm going to discuss about a very well-known assembler which can be used to execute your 8086 assembly language program that is known as EMU8086. That is 8086 emulator. So suppose if we write some programming assembly language, your 8086 doesn't understand your assembly language program. So your assembly language program has to be converted. Your assembly language program has to be converted to machine language. Now, for that, you have MASM software also using MASM. Also, you can use assembly language code uh, and that code easily converted to machine language so that your processor can easily understand. So this MASM is a uh, assembler. BLER. So assembler means, if you write any code in assembly language, your 8086 processor won't understand. It has to be converted to machine language code. Now, who is going to convert this assembly language code to machine language code? Your assembler. Okay, that is known as the assembler. So MASM is available to do this process, which is working as an assembler. But what I found that in MASM, the way we are writing the code, it is somewhat complicated and so many things we need to remember and we need to understand so many things and so many extra lines we need to add to execute the code and many steps we need to follow. So sometimes it is difficult for us as well as for the student also to remember all those steps and execute the program. What I felt. So in a very simple way, we can execute our program by using this 8086 emulator without using the MASM software. Okay, MASM also you can use, but what I found that compared to your MASM, this EMU8086 is comparatively a simpler method. Okay, where you can easily use your own assembly language program, whatever you are using for your theoretical subject. Also, suppose if you have 8086 in your theory subject, whatever the codes you are writing, whatever the assembly language programs you are writing, that similar type of code you can write in this case also in emulator 8086 and it will be used to execute that program. It's a very simple software what I found out. Now, how to get this software? So in Google, you can simply search EMU 8086. So here you can see uh, this Softonic is there. So from here I have downloaded, or you can download from other side also. I downloaded my emulator 8086 from this particular link. You can use your other links also to download this program, or you can directly download from this site. And it is hardly of 3 MB memory. You can easily install this one. Simple steps you need to follow to install this software. Okay. Now I have already installed this emulator 8086. I'll show you how to write the code. Okay, so you have to select a new one and you have to go to this option, boot template for creating floppy disk boot record. From there, empty workspace. In this fourth option, you need to go to empty workspace and then OK. Okay, this is somewhat similar to your script file of MATLAB also. The way you used to write your code in MATLAB, this is somewhat similar to your script file of that MATLAB only. So here you can write your own code. Suppose initially we will show a very simple code. We are trying to add two numbers. to hexadecimal number, and suppose each of the number is having 8 bit. So in that case, what we need to do, what program we need to write, that I will show here, and then I'll execute the program. So very simple program will do. Suppose two numbers, one of the number is suppose 22, another number is suppose 33. Okay, two numbers are given and each of the number are hexadecimal number, suppose. Okay, now you need to add this number and you need to get the result 55. All of you know very well. Now, so here we are taking a, so you know this is hexadecimal number. If you want to represent it by binary, each of the number has to be represented by 4 bits. So how to represent this two, you know, this is 0, 0, 1, 0. And how to represent the second two, that is also 0, 0, 1, 0. And take the second number, that is 3. First 3 means 0, 0, 1, 1. Second 3, for the second 3 also we need to do the same process. This for the first 3 and this for the second 3. So for second 3 also 0, 0, 1, 1. Now you add these two numbers, this 1, 1, 1, 0. Then one carry will come, this 1, 0. Like similar process you need to follow. This will be 1 and this is 1, 1, 0, and next one is 1 and this 0. So 0, this combination is nothing but 5, 5. Okay, in hexadecimal. Okay, so this is a very simple one. So you know we have taken an 8-bit number in each of the case, means we are taking two 8-bit numbers to do the addition. This is also 8-bit number. This is also 8-bit number. I am telling 8-bit with respect to binary representation. This is, you know, the left side part, this is your hexadecimal representation, and the right side part, this is nothing but your binary representation. It is having the index of 2, binary index. It is having the base index of 2. Okay. Now if you again convert it to hexadecimal, this result that will be converted to the value of 55 in hexadecimal. So there's a very simple program that will try to execute, okay, by using emulator 8086. Now you can directly go to that software to execute your program. Okay. So here you write down the instruction. You have to write in capital letter. I don't know whether it works for small letter or not, but generally what I saw that it is working for the capital letter. Your syntax has to be in capital letter. So write down move, then take first register as AL, where you can take the value of, I think the two values were 22 and I think 33. So we can take 22 in AL register and you have to give age to show this hexadecimal representation. Then the second one you can take move, then you can take BL, the second register as 33H. So in the first register of the 8086 means first register you are considering as AL register, where you are keeping the value of 22, and second register you have considered as BL, and there you are keeping the value of 33. Now you can add this register content. So write down add AL comma BL. So what is the meaning of this instruction? This is adding the content of AL and the content of BL. So what is the content of AL? 22. And what is the content of BL? That is 33. Why we have taken AL and BL? Why not AX register and VX register? Because each of the number is having 8-bit in binary representation. So that's why you have taken AL register and BL register. If it is 16-bit number, then you could have taken AX and BX. If each of the numbers were 16-bit numbers, then you could have taken AX and BX. As each of the number is 8-bit number, you are taking AL register and BL register. So I will show one program where where I will show that 16-bit number also can be easily added. The next program I will show. In the next program I will show. After writing this one, suppose you want to store your result somewhere, so you can write move, because you know if you do some addition operation, the result will be stored in the in this left register. Means if you have written add AL comma BL, it will do the addition of the content of AL register and BL register, and it will be stored in the AL register. So what register you are writing in the left side, there it will be added. Okay. So you have to show the result in some memory location. Suppose we are taking 1000. Okay, in that memory location, we are going to save our result. So that's why I have written 1000H, because H is very much important here. Without H, it won't work. 1000H, and you are storing the value of AL, because the whatever the summation result you got by using this add instruction, what it is doing, what is the meaning of add AL comma BL? You have done the summation of the content of AL and BL, and that result is stored in the AL register. Okay, so the summation result, whatever stored in the AL register, that you are keeping in some memory location 1000. So we will try to see that result. Okay. So what you need to do, first of all, you need to save your program file, save as, anywhere you can save. I can save in desktop also. So I can give the name of my code 1.asm. Definitely should be my code 1.asm. Okay, then you can save the program. Okay, after that, what you need to do, you need to emulate. Okay, so you do the emulation. Now what you can see, okay, so what you can see, this program, whatever you have written, this is coming here. This move AL comma 0 to 2H, you can see here, it is, everything is written, and where you are storing the result, that is also written. Now after that, what you need to do is you can run the program, or what you can do is, first of all, you can check what is the content is there in 1000 each location. So for that, what you need to do, you need to go to view, then after that you need to go to memory. Okay, so after going to this memory, you need to write 1000. Why? Because you are trying to store the result in 1000 location. So you go in you go to 1000 location and check what is the previous value, or by default value is coming. So enter, you check, this value is nothing but 00. Okay, and you know, in the right side, if you go to the next one, this is showing the content of 1001 location. Next one is 1002. Next one is 1003. Next one is 1004. So like that, in the right side, if you go to this array, the left one, the left extreme left of the array is indicating 1000 location, and the extreme right of this array is indicating 1009 location, because see here 10 contents are there starting from 1000 to 1009, and 1009 is not written. You need to understand in a very easy way. This one 000, the second one is 1001, 1002, 1003. If you keep on representing this way, this number is nothing but 1009. Now you can see, again you need to come to the, now if you come to the next line, then this starting address is, you can see in the left side, it is written 1010. So this value is 1010 content. The second one is 1011 content. Then third one is 1012 content, 1013, likewise you need to go. So in each of the array, 10 elements are there. You can see in each of the row, 10 elements are there, which is representing the starting address of 1000 to 1009. So if you come to the second line, you can see the starting address is 1010, then it will go up to 1019. Then if you come to the third row, you can see 10202, it will come up to 1029. So 10 contents are shown, okay, in each of the row. And this address is, starting address is shown in the left side. Okay. Okay, so you can see here the currently in 1000 location, the default, by default value is coming 00. And after executing the program, we need to see whether it is getting updated or not by the content of AL. So because as we have doing the addition of 22 and 33, we are supposed to get the result of 55. Now you run the code and check whether you are getting 55 or not. You run the code. Yes, your emulator has altered. Oh, okay. One line I have missed here. You can do one thing that is very much important to add one line here. If you come to original code, because I have not written HL. Okay. First of all, I need to check whether it is coming correctly or not. Otherwise, I can. Oh, yeah. I need to add the line here, not there actually. default I missed there. You need to write in every program, whatever you are writing in 8086, after any of the code, you need to write this halt instruction. That is very much important. So I'm doing it here again, that I missed in the previous time. So you can again check in 1000 location, it is showing 00. So now I will run the program and check whether it is getting updated or not. So I have run the program. The emulator is halted. Now I will see in 1000 location it is C. In 1000 location, the value it is showing 55. It means that whatever program we have written, this is correct only, because what result we are supposed to get in that 1000 location, we are getting the same result. Moreover, here also you can see in this register the values are written. AX value is showing 55. Why? Because AX is getting updated. You have done the addition of two numbers, and after the addition, whatever the result you have got, that must store in AX register. You know, if it is AX, the right side part is showing the AL content, and this left side part is showing the AX content. Sorry, AH content. Okay, because combination of AH and AL is known as AX. Likewise, if you see the BX register, the left side of this BX, you know, that is known as BH, and the right side of BX is known as BL. So as I have taken BL, you can see 33 is coming in the BL part. Okay, so these things also you can see here. Instruction pointer 0009 means if you come to this all instruction, this when you have executed, you know, after executing every instruction, some address will be updated, and that address you can find in instruction pointer. So this code has taken this address of 0009. Means if you have started from 0000, after executing this all this instruction, the last updated address is 0009, that will be stored in instruction pointer. Okay, that is very easy to understand. So this is a very simple code. What I have shown here, you have seen how to get the result. Now come for the next program where I need to add two numbers, and each of the number is having 16-bit. So we'll take the example of 16-bit. You can take similar type of example. Suppose we are taking 2. So you know, in hexadecimal, if you're taking 4 digits in binary representation, it will be 4 into 4 means 16 digits are there. So 16 digits means 16-bit number. Now likewise in here also you can take 3333. This is actually hexadecimal number. Each of the number I am considering as hexadecimal. So if you do the addition, the result should be 5555 in hexadecimal. Okay, so you know this hexadecimal representation. In hexadecimal, if you are writing 4 digits in binary, it will be how many digits? It will be 16 digits, because each of the digit will be represented by 4 digits in binary. Okay, so 4 into 4 digit, so it will be 16 bit of number, 16 digits. So it is, so what does it mean? We are doing the addition of two 16-bit number in binary. Okay, so that I will show here how to run the code. You go to the program, main program. Here you take this 2. Now you cannot take this 16-bit content in AL register, because in AL you know only 2-bit content you can take in hexadecimal. So in if you want to take 4 digits of hexadecimal value, then you have to select AX register. It has to be a 16-bit register. Okay, then here also BX you need to take, because you are adding 2222 with 3333. Okay, so 3333 means in binary it is having 16 digit or 16-bit number. It is a 16-bit number. Though in hexadecimal it is 4 digit, in binary it will be 16 digit. How? 4 into 4. So as it is 16-bit number, you have to take BX register. In this case, BL will not work, because BL can store maximum 8-bit of data. Okay, now you have to do addition of AX and BX. Okay, and that result I want to store in 1000 location again. You know, each of the memory location store each of the, you know, it's a very simple thing to understand. In your theory also you might have gone through these things. Each of the memory location in 8086, it will store 2-bit of hexadecimal data. As your answer is having 4-bit of hexadecimal data, so first 2-bit will come in 1000 location. So by default, the second 2 bit will come in 1001 location. If you don't write in the program also, you'll see in the result, it is by default, it will be coming in 1001 location. The next two bit digits will come. I don't know whether you have understood or not. For example, if you take this addition result, this first 50 of this left two digits will come in 1001 location, because I have given this address in the program. If you don't give the next address also, by default in the result you will see this next 55 is coming in the address of 1001. Okay, so this 55 will come this 1000 location, and this left hand side two digit will come 1001 location. Will show you. So if you don't give this address also, by default it will come. I will show both the cases. Suppose I am giving only the first one. So what it will do? Uh, Still you will get the first two digit in 1000 location and next two digit in 1001 location. Okay, let me execute the code first. So first you emulate. Then in check in 1000 location 00 value is there. In fact, in 1001 also 00 value is there. Now I'll run the code and I'll check whether it is getting updated or not. Now you run the code, emulator is halted. Okay. Now you go to this memory address. So you see this 1000 also 55, and you know the next address is nothing but 1001, that is also 55. So if you don't write anything in the code also, still the next digit will come in the 1001. But for our purpose, we will write down the next address also. It's up to you totally. If you want, you can write. If you don't write also, it will by default it will come. Or this way also you can write, like you can save the AL content in 1000 location, and AH IR 2 bits you can store in 1001 location. This also it will work. Okay, so you see, I have not till now I have not run the program. The by default values are coming 00 in 1000 and 1001 location. Now if you run the code, after that you can check what is the value are coming in this location. You can see 55 came in this location. So this is very simple. This emulator 8086 is very simple software. You can see the things more clearly what I have observed. So I found it this is very much easy compared to your Masm software. So you can use this one. Okay, so in theoretical means in theoretical case, whatever the programs you have written by putting some levels. Suppose you are having some you are using some jump instruction or jump criteria in your program. So that time you might have written some level. So that level you can directly use in this code, maybe which is not possible in case of Masm. Okay. So you no need to calculate the address of those instruction. In a very simple way, you can easily write down these levels, and this will do the jumping if it is required, or the conditions are there. If you have to jump some from one location to another location by using the level only, you can easily jump if you use this emulator 8086 software. Okay, so for that I'll show one program. Then I'll run the code there, and that will be very much easy for you to understand this thing. Suppose we are trying to find out the smallest number. Suppose we are trying to find out the smallest number. Okay, using 8086 assembly language code, assembly language program. Now, the entire idea to find out the smallest number is very simple. Suppose before going through the discussion of the programming part, let me take one example. Suppose we are taking five numbers. One of the number is 05, 03, 08, 04, 01. Suppose these five numbers are there in your program. Okay, this is one array. These five numbers are there, and you need to find out the smallest number. So what you have to do? Generally, before going through the program, generally what we do that I'm going to discuss now. You don't, I'm not directly going through the program. First, one example I have taken, and generally what we do in our common understanding that I'm going to discuss. Okay. So first what we do, suppose what we have to do, suppose we make a comparison between the first two numbers. Okay. So which one is small? 03 is small. Okay. So you save the 03 in somewhere. Okay. Okay. Then that 03 you can make a comparison to the next number. Okay. So out of the 03 and 08, which one is the smaller one that you save? Okay. So if you make a comparison between 03 and 08, in this case also 03 is small. So you keep as it is in this. Suppose you are taking one register where you are storing the value, and that register is suppose your any register you can take. Suppose I am taking AL register. Okay. Suppose I am taking AL register to store this value. Okay. So when we are making some comparison, in every comparison, whatever the smallest smaller element is there I am putting in AL register. Okay. So likewise, I have made a comparison between 03 and 08 and I found out the 03 is the smaller one compared to 08. So I'm putting it in AL register again. I don't have to update anything. Now you come to make a comparison between 03 to 04. Now in this case also you can see 03 is smaller than 04. So still 03 is there in the AL register. Now you make a comparison between 03 and 01. Which one is smaller? 01 is smaller. Immediately you update the content of AL register. Okay. So what is the main uh, funda of this program is every time every time we need to compare two elements and whatever the and which element is compare and what element is comparatively smaller, then we need to keep in AL register. That is the main idea of this program. Okay. So suppose you have taken 5 content in this array. So one register you need to select to do this calculate or to do this count. So generally for count we can take this CL register. It's not like that CL only, you can take any register you can according to your requirement. So we can take CL equal to 05. Okay, because 5 numbers we have used in this example. So in the program also we'll take 5 numbers. So CL has to be 05, which has to be decremented when we are increasing the number of means comparison. Suppose if you do the first comparison, in that case 2 elements you have taken, then you go for the third element, then CL value you need to automatically decrement. Okay, as you are coming to the next comparison, again CL value has to be decremented. As you are coming for the last comparison, you need to make CL uh, uh, 1 unit less. So you need to do this comparison how many times until your CL becomes 0. So the main funda is in the starting when you have taken this first value at that time, in the initially you have considered CL equal to 0.5, and as you have taken each of the element for the comparison, your CL is getting decremented by a value of 1, and when you will come to the last element, after that, when you have taken the last element, after that your CL value will be 0. This is very easy to understand. In each of the comparison you need to reduce the value of CL value. Okay. So this is one of the register you need to take. Moreover, another register you need to take. Suppose you can take SI as the indexing register. What is indexing? I didn't tell where the 05 is located. Suppose I am considering in 1000 location this 05 is present. Then 03 is definitely 1001. Then 08 is suppose 1002. Then 04 is 1003. Then the next location is 1004. So to come to each of the element, we need to first access this location. Okay. So how to get this location? So for that we can consider one SI register, which will be incremented when you are coming for the next and next point, means next and next content. Okay. Every time you need to increment the content of SI register. So initially SI you need to take 1000. Then if you are trying to access the next element, SI will be 1001. If you are trying to access the next element, it will be 1002. If you're trying to access the next element, it will be 1003. If you're trying to access the next element, it will be 1004. Okay. So every time you need to increase the value of SI. And for that, a very simple instruction is there, that is INC. Okay. Now, as I told, here for this example, suppose you have to make a comparison between 03 and 05, or maybe 03 or 08, or maybe 03 or 04. What instruction is there to do the comparison? This is a very simple instruction, that is CMP instruction is there. So we need to use this instruction also. First of all, I am giving some brief idea about this program. Then I'll entirely discuss the main program. Okay. So what I was discussing, like if you want to make some comparison between two numbers, which instruction is there in 8086? That is nothing but CMP. Okay. So suppose if you have this, if you are using this instruction CMP AL, BL, what is the meaning of this one? So you are making a comparison between the content of AL and content of BL. If AL is greater than BL, no carry will be generated by this instruction. Okay. So if you use this instruction, your carry flag is getting affected. How? If your AL content is more than BL, carry flag will be 0. If your content of BL is more than AL, in that case, one carry will be generated in the carry flag, means carry flag will be 1. Okay, so by simply using this condition, we can find out the smallest number. Now come to the main program. So what we need to write? Suppose move. We are writing SI equal to 1, SI comma 1000 means I have taken the first address in SI register. Suppose in what are the values I considered that time? 050308. So you can easily see in 1005 is there, in 100103 is there. I'm considering like that way. So after that means after executing the program, you need to find the smallest number as 01 according to this particular example. Okay, so at the starting address, I'm considering 1000 is the starting address. So that I'm keeping in SI register. So I have written move SI comma 1000. So after that, what you have to do, you need to take another register which will do the count, operation. So for that, I am taking CL register, CL 05 H I am taking. Okay. Then after that, what you need to do? You need to take the content of SI into AL register. So you know this is a very simple instruction. The first content, whatever it was there, if you can remember, what are the elements we have considered? Let me write down here again 05030. So you can write it again 050308, then 04, then 01. Okay. These are the contents, and the address are 1000, then 1001, then 1002, then 1003, then 1004 for this corresponding element. So what we have done, the first content means SI is indicating 1000 location. So in square bracket of SI, it means the content of this 1000 location, that is 05. I have taken in AL register. So AL register is having the content of 05 now, according to your this instruction. Okay, move AL comma SI. Now what you need to do, as you have taken the first element, so immediately what you need to do, you need to reduce the content of CL, because first element you have taken. So how many element you need to access? Remaining elements are 4. So that's why you need to immediately, as you have taken the first element, immediately you need to reduce the content of CL register, DEC CL. Okay. Now what you have to do? Now you need to take the second element. So what you have to do, if you have to take the second element, you need to update the address of SI. So how to update the SI content? So you need to increase the value of SI. So what you can do is you can use the simple instruction INC SI. Now it means that you came to this location, because as you have incremented SI. So what is the meaning of this INC SI? It means that the content of SI is getting incremented by value of 1. So previously SI was 1000. Now as you have executed this instruction, or as you have written this instruction INC SI, it means that you have come to 1001 location. Now that location content you can take in another register. So suppose you can write move BL comma SI. So 1001 content you have taken in BL register, and the content is nothing but 03. Now you can make a comparison between this 03 and 0L. So for that, what you have to write? CMP AL comma BL. So what you are doing? You are making a comparison between the content of AL and BL. Okay. So what you have to do? If AL is smaller than BL, If AL is smaller than BL, you know, in the previous slide only I discussed, if the content of AL is smaller, means if you have written this type of instruction CMP AL comma BL, if AL is smaller compared to your BL, at that time your carry flag will show some value, carry flag will show the value of 1. Okay. Now for this particular example, whatever till now we have shown 05 and 03, 5 was there in the first and 03 is there in the 03 there in BL element, you know, no carry will be generated because AL is greater than BL. Okay. So uh, uh, if means no carry is there, what you need to do? So I already told the main fund of the program is you have to compare two number and which number is smaller, that immediately you need to take in AL register. So for that, what you need to do? You need to write move AL comma BL. So for this particular case, whatever just now we have shown, for this case, you need to come to this instruction move AL comma BL. Why? Because you have seen AL is having the value of 0.5 and BL is having the value of 0.3. As your AL content is higher than 0.3, immediately you need to move the 0.3 to your AL register. That is our main purpose. What I said, when you are getting a smaller value, that immediately has to come to AL register. So that's immediately the content of BL I have kept in AL register. Now 0.3 is coming to 0.3 has come to AL register. Now AL register is having the value of 0.3. Now, if the case was different, if the case was different, it is not like that for every program, maybe zero means for every example, 0.5 can be there in the left side, 0.3 can be there in the right side. That is not certain. In many example, it can be there 0.3 in the left side and 0.5 in the right side. Means 0.3 is the first element and 0.5 is the second element. In that case, what we need to do? In that case, you know, if you see this example, this see this instruction actually, CMP AL comma BL, it means that carry flag will be 1. Why? Because the content of AL and BL, if you compare in this particular example, then you can easily understand that your AL is smaller than BL. Okay, so AL is smaller than BL means you no need to transfer anything. You no need to shift the content of BL into AL, whatever we have done in the previous case. So what you need to do? You need to directly jump. So after compare instruction, you can write jump carry to some level L1. So what is the jump level? So you need to come here. This is one level actually. You need to come here. Directly you can decrement the element of decrement the content of CL. You no need to do this instruction, you no need to perform. This is the meaning of jump carry. So jump carry, you are coming to L1 address and L1, you know, this is the L1 address. You no need to execute the move AL comma BL instruction. Why? Because in this case, you see 03 is already there in AL register. So if you execute this instruction again, what it will come? 05 will come in AL register. That is totally wrong because our main target, whatever the smaller number is there, that has to come in AL register. Okay, so here both the cases I have shown in the program. If AL is smaller, then you no need to shift the content of BL to AL. So directly what you need to do, you directly jump from this instruction to this here. You no need to execute move AL comma BL. That's why I've given this if condition like JC L1. It means that you are coming to directly L1 location, means this instruction DECL unit DEC CL actually you need to write. You need to decrement the content of CL. Okay. Directly in this instruction you need to come. Okay. You no need to transfer the content of BL to AL register. Okay. So this operation, suppose this comparison, how many times you need to do until the content of CL becomes 0. So for that, what instruction is there? That is J and Z. Okay. You know, as you are decrementing the content of CL in the previous instruction, this thing you have to means this decrementation of CL has to be done how many times until the content of CL becomes 0. So uh, after this instruction, what you need to do? You need to jump to a particular address again to do the same steps again and again. Where you need to go? You need to come to this location. You need to come to this address. Okay, so if you have performed the first comparison, then what you need to do? You need to now increment the content of SI. That's why I jump to this location. You have increased the content of SI to the value of 1. That's why INC SY means you have come to 1002 location. You take the content 08 in the BL register. Now make a comparison between 03 and 08 and see which one is smaller. If AL is smaller, directly come to decrement of CL. If BL is smaller, then you have to move the content of BL to AL register. That is the entire idea. Okay. So after that, when this DEC becomes 0, then you have done all this comparison, all the 5 elements you have accessed. Now you have the smaller value in the smallest value in AL register. Now you can store that value. So you need to write move. You can take one address, suppose 2000 location. I am trying to store the value, smallest number 2000 H, comma AL, and you need to write halt. This is the entire idea of the program. Okay, so you can write this program in the emulator. Let's see, let's see. So what is the program we have written? Suppose first line move SI comma 1000. So we'll write down move SI comma 1000. Okay. And then after that, what we have to do? We have to take the second register CH for the count operation. So we can take CH. So you can come here CH, where you can take the value of 05. As we are considering 5 numbers for the comparison. If you want to take 10 numbers, you can take the value of CH as 10. Okay. Then what you have to do? Then you have to move the content of, let me delete these lines. So what you have to do? Move uh, the first element you are putting in AL register initially. Okay. So after that, as you have taken the first element, you have to immediately decrement the content of CL. Means one element you have already taken. Now CL has to be 4. After that, what you need to do? You need to access the next data. So as you have to take the next data, you have to do increment of SI so that it can come to the next address. After that, what you need to write? Move that content to another register BL so that you can make a comparison between AL and BL, the content of AL and BL. So, okay, BL. Okay. Then after that, we have to make the comparison CMP AL, comma BL. Okay. Then after that, you have to give the condition. You can jump to directly AL level uh, if your carry is there. If your carry is there, what does it mean? AL is smaller. AL is smaller means AL is already having the value of the smaller number. You don't have to do the movement of BL content to AL content. But if this condition is not satisfied, then it means that AL is larger, BL is smaller, having the smaller number. So in that case, you need to move the content of BL to AL. If the condition is not satisfied, it means that BL is having smaller number, AL is having larger number. So in that case, the smaller number BL has to be moved to AL register. Okay. So both the condition we have shown. So you have to jump to this L1 address. If jump carry condition is satisfied, at that time you no need to move the content of BL to AL. You can directly jump to L1 address. And in that case, what you need to do? You need to decrement the content of CL register. Okay. How many times you need to do the decrement of CL register until your content of CL becomes 0. So we are trying to jump to address. So until your CL content is 0, you need to jump to this location to perform this comparison again and again until you access the 5 elements. Okay. And after that, you have to store the result in some location. Suppose 2000 location, you want to store 2000 H. There I want to store the smallest number, and after this execution where the result will be stored in the smallest number will be stored in AL register. The result is stored. That content, smallest number has to be transferred to 2000 location to show the result. Okay, and LT halt HLT. Now what you can do, you can emulate. Okay. Now, see, in this case, what you can do is first you cut this one. So you go to view, go to memory. So in where I'm keeping the where I'm which address I have taken as the initial address for SI, that is 1000. So you write 1000. Enter. So check what is the content there. By default content is 0. So you can take 5 numbers. So what example I have considered that I can take 05030804050308. 05, you write down 050308. Then next one is 0401. 0401. So you have entered the values in different locations starting from 1000 to 1004. So all the 5 address means in these 5 addresses, whatever the contents are there that you have updated by your own choice. Okay, I have given the values of 05, 03, 08, 04 and 01. Now what you need to do, you need to update because you are updating. By default value was 0000 and you want to update your own value in this location. So that's why you have given these values and after that you have clicked on update. Okay, now we'll run the code and we'll check whether in 2000 location you are getting these values or not, getting the smallest number or not. So now you run your code. I think I have missed something in this code. Is it? Oh, no. Okay. Okay, now let me check. So go to view and then memory. So where I stored the value in 2000 location. So first of all, let me check. Let me write down 2000, enter. 2000 location. Is it there the smallest number? No, it is not there. So I think I missed something in the program. Move SI 1000, then CH. Oh, yeah, I have taken CL. Okay, but by mistake I have written CH here because I have considered the register as CL. So here I cannot change. Here I need to change actually. Though I have taken CL as register which will be decremented in every iteration, but mistakenly I have written here CH. So that's why the main problem came. Whereas I think here I have written CL only. Yes, correct only. So that's why the problem came. Now I think you will get the result. Okay. Now we can emulate. Yeah. First of all, we'll check this value is still there or no. We need to update the values again. So what are the values we have taken for our own case? 050308. 050308. Oh, 0 0 5 0 sorry 5 0 5 0 5 0 3 0 8 then 0401 if I am not wrong. I think 0401. Okay, now update. After that, you run the code. Okay, now I think it will work. Now you go to view where you have stored your result. You have stored in 2000 location. So go to memory here, write down 2000. enter. Now you see the smallest number is stored in the 2000 location, which has to be 01. Okay, so that is the main thing. When you are writing the program, you have to be very careful. So in the previous case, what I have done, one simple mistake I have done. In case of CL, I had written CH, so that's why I couldn't get the correct result. Now, as I have changed this one, I have entered the correct thing. Now you can see that we have got the correct result. So when you are writing the program, you have to be very careful. This simple mistake can do a lot of thing in your main program. Okay. Now I think all of you have understood how to run this code in 8086 emulator and how to see the result, how you can update the content of the different memory location and how to see the result. Okay, so I found it this is very much simple compared to your this Amazon software. Okay, thank you very much.